In this video, I'm going to wrap up the lesson on functions. A function, also called a routine, a subroutine, a procedure, subprogram, or a method, is a reusable named block of code, which basically saves us from having to retype the same code over and over again. I mentioned it's called a function or a routine or a method. Now, for the most part in C++, we stick to functions. In some texts and in some other courses, you may come across these other terms. I also mentioned that another term for a function is a routine or a subroutine, because we have something called a coroutine, which was introduced in C++ 20, and that is a function that can suspend execution and then can be resumed later, so that is very handy in some cases. When the time's right, we'll learn about that in the module C++ 102. A recap on encapsulation: to reuse code, we encapsulate it. This means we put the code in a named, self-contained block of code, such as a function. Now, the process of encapsulating the code is called refactoring. Alright, refactoring is the systematic process of improving the design or efficiency of the program, that is, without altering its behavior. Again, we do this to reduce repetitive code, to reduce the file size to have fewer lines of code, and that is also ultimately going to improve debugging efficiency, because let's you have the same lines of code repeated in your file 10 times and you want to rename something such as a variable, then you have to go and rename it 10 times instead of just once. The rule of thumb is if you see code repeated more than twice, then you want to go and refactor that code. As I mentioned, you also keep your main function clean. That is because you move whatever you want to do to some function. A function should be usable as a black box where the programmer is not concerned with the function's implementation. This refers to abstraction, where we hide the implementation details to reduce complexity and increase efficiency. We just use existing functionality and we are not really concerned with how it is implemented. How the function works, now not how it is implemented but how it works, should be evident from its name, parameter list, and accompanying comments. As demonstrated in the lesson, we can use functions from the standard library or from third-party libraries. Again, we don't have to reinvent the wheel each time. We can simply use existing functionality, which has been tested over many years. Also, as demonstrated, function definitions within other function definitions are illegal. So in other words, local function definitions are illegal and will give you errors. You can call one function in another function's body, but you cannot define a function within the body of another function. Next, I want to talk about something that you should try and avoid as a beginner, and that is recursive functions. A recursive function is a function that calls itself, and you should avoid recursion until you learn more about it in the module C++ 102. You can see a quick example here. We have this void function inquire. We have two console output statements in the body of the function, but then we have another statement here where we call the function itself. What do you think is going to happen when you do that? Well, we call the function itself. It's going to do the console output statements, and then it's going to call itself again. But it's never going to return to the original caller, which is going to be likely the main function, whatever the calling function might be. This is similar to the infinite loop examples that I showed you in the iteration statements. There are ways of avoiding this, and recursive functions are actually very useful in C++, but it's best to avoid them until you learn more about them in the module C++ 102. I'm mentioning this here in case you run into issues. To explain to you what the problem with this is, and what the stack is, I have to show you a few examples. A stack is a data structure in which the addition, deletion, and retrieval of elements are restricted to occur at the top of the stack. It's like a stack of coins or a stack of books, but we are only allowed to add, retrieve, or remove elements at the top end of the stack. So in other words, if you have a stack of coins, you're only allowed to add, remove, or basically view the top coin of the stack. Retrieval refers to the fetching of the data, so in other words, similar to how you would fetch a value from an element within an array. Coins can be different, right? The top coin can be 5 cents, it can be 1 cent, and so on. So we want to retrieve that value, or you want to add another coin on top of the stack, or delete a coin from the top of the stack. I prefer to introduce things to you step by step, so I'm only talking about some of the things, some of the memory segments, and I'm showing you simple examples, but we will expand upon those in the module C++ 102, and at that point, you already have a basic understanding, right? That is my goal. I want to introduce it to you step by step, instead of all at once. I mentioned these memory segments previously in the lesson, and the stack stores function parameters, local variables, and keeps track of currently active functions. To start off with, let's look at an example that works correctly. So we have the main function example to the left, and the stack on the right. Currently, we only have the main function on the stack, and within the body of the main function, we invoke the function 1. Just as an example, program execution moves to function 1. Something called a stack frame is pushed onto the stack. That will include stories for local variables such as the parameters and other local variables. We execute whatever is in the body of the function. In this example, in the body of function 1, we invoke the function 2. Program execution again moves to function 2, and we push a stack frame onto the stack for function 2. We execute whatever code is in the body of function 2. Once we're done executing all of the statements within the body of the function 2, we return to the calling function, which in this case is function 1, and we remove that top element of the stack. So we remove that function 2 stack frame from the stack. We execute whatever statements are left in the body of the function 1, and then program execution will return to the main function, which was the calling function for function 1, and once again we remove the stack frame for function 1 from the stack. Now that we have a basic understanding of the call stack, let's look at this example again and why this function will cause a runtime stack overflow. To the right we have the stack, so let's say in the main function we invoke this inquire function. That is going to create a stack frame on the stack for the inquire function. But what do we do in the definition of the inquire function? We do those console output statements and then we call inquire again. When we call inquire, what's going to happen? It will push, or in other words add another stack frame onto the stack for the inquire function. And this is going to repeat until you get a stack overflow. Program execution will repeatedly call and move into new inquire functions. A quick example in Visual Studio, I have this void inquire function, and this function will cause runtime stack overflow because in the body of the function you can see we do console output, where we have those two console output statements, but right here we are actually calling the function itself repeatedly. So if we call inquire right here, it's going to call inquire, okay, and then it's going to do those console output statements again, and then it's going to call itself again. In the main function I call that function inquire, and when program execution moves to the body or executes the body of that function, again it's going to call itself. You can see the problem that we have here. This is like an infinite loop. It's going to keep calling itself. I'll build around that and you can see the problem that we have. It's going to keep printing the stuff out. Are we there yet? No. Are we there yet? No. Are we there yet? No. And so on. And eventually it's going to crash. You can see we get this recursive warning. Function will cause runtime stack overflow. In previous lessons I mentioned that you want your process to exit with code 0. Now in many of my examples that doesn't actually show up in the console, and that's because of a setting turned off. Or turned on actually. I'll go to Tools here and Options. Then under the debugging section, if I scroll down, have this option checked. Automatically close the console when debugging stops. Turn that off. Now the reason why I have that checked is because when you do debugging, then often that console window hangs around and you sort of forget about that, and then you have to close that manually, so that's why I have this turned on. But when you have this turned on, it doesn't show that process exited with code 0 at the end, so I'll turn this off, and if we build around this again, we will get that are we there yet? No. Are we there yet? No. Are we there yet? No, constantly until it basically crashes. Now we will see here process exited with code minus something, this huge value here. That is not 0. We want exited with code 0 as I mentioned in previous lessons. I'll comment this line out here. Now this function will no longer call itself recursively. Build a run. And we will see that process will exit with code 0. And with that you know that the program did not crash. Okay, before I end this video off, I want to talk about functions that return a bool type. As I mentioned when I introduced the boolean type, you can prefix boolean variables with a lowercase b character. B as flag for example, or b logged in. I prefer this convention. It's also an Unreal Engine convention. This really makes it easy for the reader, so you as the programmer or some other programmer, to see that okay, this is a boolean variable. Now similarly we want to do that for functions. We want the function to be easy to read and to identify as a function that returns a type of bool. So functions that return a type of bool should ask a true or false question, such as bool is equal, or is coffee warm, or is light on, right? Or should I run as a silly example. Because let's say you want to call that function within an if-else statement for example, and based on what that function returns you continue or not. Now again, in that case we want to make it easy for the reader to understand that okay, this function is going to return true or false. So in other words, it returns a type of bool. Okay, as a quick silly example in Visual Studio, I have this function bool is equal. It has two formal parameters, int x, int y, and it's going to return the result of this test. So it's going to test for equality. We have the equality operator here with x and y as operands. Again, this function returns the type of bool. Okay, in main I have a silly example. I have character 1 power level which I initialize to 9000, character 2 power level, which I also initialize to 9000, and then I do a bool is equally matched, and then I can do is equal, and I pass in character 1 power level and character 2 power level, and of course that is going to return true or false. In this case it's going to return true, and with that we are going to initialize is equally matched to true. Then I have this if statement, is equally matched. Now you can also do be equally matched, like that. Instead of doing is equally matched, you can do b, lowercase b, equally matched. And to the reader or some other programmer, it's going to be easy to see, okay, this is a boolean. It really depends on the convention that you want to follow. I prefer to use this sort of convention. And then for the function name or identifier, if it's going to return a type of bool, then it has to ask some sort of question, true or false question. So if equally matched, I'm going to print something out. Build around that, and you can see that works fine. Of course, instead of doing that right there, you can also, I'll just copy that and paste that in here. We'll call the function, it will return true or false, and based on that we will execute the if-else statement. In this case we do not have an else part. Alright, let's just build around this, and that works fine. And again, the goal is to make it easy to read, so in this case you can either use a boolean variable to store the result, or you can call it in the if statement, so between the parentheses. We can call it right here, and this is easy to read, right? Is equal, and based on the name of the function we know that that is going to return true or false. That is it for this lesson wrap-up video. I'll see you next time.